Hello, this is Randy, and I'm going to try doing another code commentary on vector source code. So I'll begin digging into how the face works on vector. That is, how his eyes are animated, and then how they're drawn and make it to the way to the display driver for the LCD. So before we go too far, I think it would be helpful to kind of try building up a mental model of how the face and display works. This kind of helps organize how we'll dig into some of the source code and where we'll look at. The animation file defines the shape and size of the eyes and where they are positioned. The steps in the animation file are modified by the procedural face module to give the eyes lifelike characteristics and to break any creepy staring effect. The procedural face adds in blinking and squinting steps and causes the eyes to dart or change focus from time to time. This may be influenced by the current stimulation level or mood of the robot. The eye animator takes the combined animation steps, those keyframes and their transitions, and computes the intermediate values for all of the eye parameters for each image frame. Then the eye renderer draws the eyes into a frame buffer in a sophisticated fashion. Then the frame buffer is sent to the LCD. What I will look at this time are the face display modules. These modules coordinate controlling the LCD and transferring the frame buffer to the LCD. The code has some ability to target different kinds of displays. The most important case is the LCD on vector. The software uses the same code as boot anim to send frame data to the LCD here. But it has a thin wrapper module, faceDisplayImpl.h VicOS, that the face display code calls. The software also has some code that Anki used to run key portions of vector software in WebBots on OS X hosts. I will skip that, except for to say that that face display implementation Mac file has the same software interface that face display uses, but otherwise it just wraps around calls to WebBots display code. Let's look at the face display implementation header file. It has a good comment block at the top, who wrote it, roughly when they first created it, good synoptic description of what the file is intended to do. Then as a good header file, they've included this protection against multiple includes, because that's just a quirk of the C and C++ language where they kind of need to do that. Here's a types include. So that looks like that's probably going to be the custom types. They probably defined a bunch of standards of what they should call a common language types like integers and strings and perhaps containers in there so that they're using it consistently. And then there's this configuration file. And I bet you that configuration file would typically have what features are on or how big the size things and other things. That's a very good technique to do so that everything, all this application software modules, everything is using a consistent definition in one spot that you go to and you just adjust that configuration. It could be something else, and maybe they call it config and it actually is doing something I'm not guessing yet. I haven't looked into it enough. They do call it Cozmo. That's because all of this was originally developed for the Cozmo product and then extended for Vector. But also, I believe that they called Vector while it was being developed something in the Cozmo family, and so we call it Cozmo Next Generation or Cozmo something else. Who knows? Then they use namespaces. This is a good practice if you're not familiar with it. What the idea is so that because there's so much software and third-party code could be created that might get used, and it could also use the same kind of names for procedures and classes and methods and other things. This helps isolate the code here so that the two won't collide. That is to say, you won't cause conflicts, so the compiler will warn you, or you'll get strange hidden errors where the wrong thing is used. And you see this throughout the Anki code where they use a two-level namespace. The first namespace is the manufacturer name, so Anki, and then they use the product names from Vector. And sometimes they use a third level for a subsystem, but I don't see that here. They define the class for the implementation interface. Now, what you see here is that there's no virtual, no abstract. That's a good thing. What they chose to do here means that the implementation can just not take up any dynamic memory per se. It doesn't require any allocation. That's a good practice so that you don't run into issues of memory pressure or memory management issues if you don't have to. They probably looked at this and said, there's only going to be one display at a time. We're going to use that. And if we need to use the other kind of displays, we'll just choose a compile flag or compile option in that config file or one of the build scripts to switch the target display. We can see here that they have two generic meta controls. They have something to clear the face on the LCD. So that probably gets rid of anything that was previously displayed, like the boot animation, or to clear it out if they need to go to a new animation, or if perhaps they clear it out when the program exits. And then they have one down here that sets the face display brightness. I don't know if they use that much or not. I've never seen Vector's display really change. They probably just turned it on initially and maybe tweak it when it goes into a low power state. Who knows? Then they have a method here to transfer the frame buffer. As before, it's a 16-bit 565 RGB pixel thing with the face display and height. Given the lexical structure here, it's all caps and name like that. I bet you that's a pound defined someplace. We didn't see that used in a separate header file for bootAnim, but it is here, so that suggests that it's probably in the cozmoconfig, or cozmoconfig brings that in for that display thing. It's a bit pity that bootAnim didn't do that. What they do seem to have done is switch the pixel format type. It's still 16-bit, so uint16 is there, but in bootAnim.c they used uint16_t. That could be an accident, or it could be an evolution, or it could be a representation that different teams had different little working styles when they developed different parts of Vector and Cozmo for the different target hardware and other systems. And then finally we have the printf feature. So that could be for the customer care information display. It could be for debugging information while the device is in developer debug modes. I don't know. Well, we'll get into that perhaps later. Let's look at the display implementation for Vector. It's very going to use the same header file we just talked about. So let's see here. So they have another good comment block at the top of the file. That's good. A good synopsis of what it's for. They say simulated face display. I think that the simulation could be copy and paste from a different module if they were prototyping on a WebOts, or it could be that they're referring to just the mere creation of the eye's procedural face as simulated, and they just change their names later on. They're including that header file which declares that class earlier. They're also including fault codes. Interesting. They're including the same LCD.h that bootAnim used, so that's the lower level. And then they get into some logging there, and then they have the same namespaces as before, so everything lines up. I see that they've indented here, whereas before they didn't. And then so the first method, the constructor, it just goes through, it calls this LCD init. And if there's a problem, then it triggers off the display fault code. So that's going to send this display fault code out the pipe that triggers off the fault display process. It'll probably causes VicAnim to exit. I don't know. We can look at that another time. So when the this face display module is deconstructed, probably when VicAnim exits, they clean up the face, they clear that out so that there's no leftover old animation while they're switching to something else. And then they send the command to tell the LCD to shut down, or at least that LCD module to shut down. Perhaps that module does some cleanup, perhaps it does nothing, I don't know. So face clear calls that. It's just a simple wrapper around the other items. They have their face draw, which is a transfer buffer, just a simple wrapper around call. The printf does nothing, so it ignores it. So that probably is very much desktop developer debug code, and it's not used on the live robot. So that isn't even used for the customer care interface. That's done somewhere else. Again, then we have the face display brightness, and then again this common on exit procedure that was we also saw in bootAnim. I bet you that's probably another hint that LCD C file or whatever it's called, LCD.h and its corresponding C file. If they run into problems, they just call this back to clean everything up and force the application to exit. So this other common code has a structured way of calling back into here, I bet. So there ain't much to this wrapper. So that kind of leads to the question of why even have this wrapper, and just it's because you won't use this lcd.h.c on WebBots. Why not just have lcd.c for WebBots just be different? Or vice versa, why not even have lcd.c and just use this instead? And why this duplication and just really trivial wrapper? And I don't know, but I would guess that a couple different things could have happened. It could have been that the face display was originally worked out and had this item, and a different team was then going on and doing hardware development, perhaps for Vector, perhaps on Cozmo. I don't even know if the face display was run on Cozmo's hardware or if it was run in the mobile, on the app on the Android or iPhone device. I don't know. But these different teams could have been developed at one point and then made it run on Vector's hardware at a different time, and they just use a common structured way here just to wrap it around and use code that each had developed at that point and just kind of bridge the two, and just accepted that, yeah, it's a little bit of cleanup could have been done better, but they'll get back to another time. And that could have been a triage thing. Could have been other causes. It could have been other reasons that happened. Let's look at the face display module now. First, the header file here. The face display module is what calls those wrapper ones that we just looked at. And it probably provides some functionality common to just displays in general. We'll dig into it and see what we see. So it has the header file, again, has a good header at the top. It has, again, the common header protection, so it's not multiple included. It has something here called dynamic singleton. I don't know what that is. As well as some fault codes that we saw before, presumably, so if it ran into a problem, it can emit a fault code and exit. And then it has some LCD types. I don't know what those are. We'll have to kind of dig into that some other time. It could be, judging by the fact that it says clad on the front, it's probably something related to either how the application, other applications in Vector software can communicate and send commands to start and stop it or do something, or perhaps it relates more broadly so that the mobile app and the Python app and the C# and so on can send images to the display. It could be other things. We'll have to find out. We see, like we saw before, namespace, but we see a separate namespace here first. So this namespace vision, and it says class RGB565. Don't know yet, but I'm going to throw out a guess. The vision system, we know that you can turn the camera on into mirror mode in some debug cases and have Vector's LCD display whatever the camera is seeing. Cute little trick if you're just playing around. I think it kind of breaks the illusion, but it's there. I suspect that this is a key part of that the vision system, for its own reasons, has a pixel buffer for 565 pixels that it titles image RGB 565 for that type. That's just a guess. Then we see the Vector namespace here. It's giving two forward declarations here. So this is the implementation we just looked at. So that wrapper for the actual communicating with the display, whether it's an LCD or on WebBots or perhaps some other ones. Something here for the face info screen manager. That's probably the customer care or debug screen that kind of presents all that information. Then here we have the face display module. That's interesting. So it's wrapping around this thing called dynamic singleton. My guess, I don't know how this works. I haven't looked into it. I'm not familiar with this idiom per se. I'm not huge C++ application programmer. My guess is that they're intending to say that this module is either going to be going to only have one instance. That's a singleton, and they did some things to help it. That the rest of the software tends to call. It could also possibly be that they're doing some other helpers, like setting this up in its own thread to take commands and do some items. Don't really know. There is a friend singleton. don't know what that is. I'm confused there. I don't have a good guess. Here we have a similar frame buffer drawer, which takes that probably from the vision system, that's frame buffer and draws it. Looks like they have a method here to support drawing that, and they're calling it face debug as well. So it looks very similar, the two. I wonder what the different intended uses are, if there's anything that's different between them. There's a very common wrapper here that we saw before, which sets the LCD brightness, but they're using a different type now. They have this LCD brightness type. I suspect that's part of the CLAD thing where it gets some sort of configuration information or gets control from an external app. Here's a method here, which is, if judging by its name and comment, that they're going to stop that boot animation. They're probably going to send a signal, causes that boot anim to exit, and then we can take over and start the display here in Vic anim. I don't know what this draw to face internal is. Possibly, just a guess, is they take that vision system image buffer and then they copy it to a local image buffer, and then they add some extra annotation to it or extra info. That's not what I was expecting to see. They have some more things here. I don't fully know all the things that are going on. It looks like in this case that they're having a pointer to the display. So this module decided that it could actually potentially, if you had multiple of these, it could work with different displays. They are not calling it through, say, a global instance of the display wrapper, but instead they actually have it right here, and then they're probably going to invoke it through that. They have face draw image. This is members from managing drawing thread. So they have two of these. I don't wonder what they're doing with those two frame buffers. It could be that they're using one to receive new images from the vision system and then using the other to transmit out to the actual LCD display. It could be that they're doing something else. But it does kind of seem with these three things going on here that they're using these as a double buffering scheme before they transfer it. There's a thread here, so this indicates that probably the face drawing module runs on its own thread, or at least it's a link to a common thread that it's part of several other drawing steps that it runs on. It has a mutex so that multiple other parties, if they're signaling the thread trying to send it information to draw, that only one of them can do it at a time. I don't know what information they'll send it to it, but that'd be interesting to see. An atomic bool, that's good, to stop the face drawing procedure, face drawing module. So it's good that they're using an atomic bool, since it does look like it's probably signaled from other threads. A ready mutex and ready condition variable, ready face, don't know what those are. It could be that those are signaled when there's positive indication that the boot animator has stopped running. Could be something else. Oh, right here we have the atomic bool for the stop boot anim. Atomic because it is checked by the face. That's good. Yeah, it should be atomic. So this is probably the feedback from whatever it is that stop the boot anim, that it sets this so that the rest of the face drawing stuff can skip work that is unnecessary because the boot anim is still cleaning up. A loop here, that indicates that it's probably part of a thread on its own that goes through the steps of checking for events and then handling the drawing stuff. And I don't know what this update next image pointer would be. It could be managing those buffers and could be managing other pointers. Who knows? We'll find out when we dig into the code here. This is the face display code. It has a header there. That's good. Includes a bunch of the files, many of the ones we looked at before, as well as some new ones to us. Array2D, that's probably something that's going to hold pixels if it's a 2D thing. Cortex Vision Engine image, that's probably the that image buffer that has the current the current camera frame. Some sort of console interface. The console interface is a debugging tool, or that is really very clever. That lets you tweak and set a whole bunch of things on the software execution from, in this case, it's a web interface that they use. Everybody's seen it as kind of the web viz thing on developer bots and the Oscar bots. They have a CPU profiler to kind of get some idea how much CPU time is going on for the developers. Thread priority, I suspect that's a wrapper so that they can prioritize the display thread so that it is moving smoothly and not interacting. I don't know what this exec command would be. That's new. Looking at the pound define here, they set up a macro here to say where all the logging information should go for the rest of that debug environment. In this case, they call that face display. It seems reasonable. They have a configuration variable here. It says whether or not we need to manually stop the boot animation via Vic or for Vic boot anim. In this case, it's 0. Typically, with a configuration flag like that, when it's 0, that means that it doesn't manually stop it. And so that's interesting. So I would also typically, in many development contexts, there would be a single config file or just config files with nothing but these pound defines for these different options. So it's in one spot so somebody could go there, but they put it actually in the C file while they were debugging and working on it. So this is probably intended for the single guy or a couple guys that are working on debugging and developing this face display driver. So they have the same namespace as before. What they have interesting here is this if-this. So this is probably this if Anki CPU profiler enabled is probably defined in one of those config.h files. And if it's not enabled, they probably aren't tracking the time and resource utilization of Vector, or this particular module in this case, but overall all the modules in Vector software. But when it is there, they do track it, and you use a console variable here that they can watch in the web display. So we have console var range, which these are macros that they use to set up the things that make this variable, which is right here, this max draw times ms, which is milliseconds, so that it can be used by the actual software, but the rest of it sets up whatever it needs to set up using their templates and other items so that it actually is known by this debug interface, this web visual console interface, as well as tells it the kind of acceptable ranges of values that it can display and how to group that. We see one here for enumerations, and this is for how it logs what's on the face, what it draws. Probably how much time it spends, or if it's maybe it's a Boolean there, which controls whether or not it's actually logging that to a file, so that you can look at it later, versus the max time is the worst case. Who knows? Now we'll find out. So there's an anonymous namespace, so they can have these, but no other module outside of them will use them. It's just only used in here. They have an if remote console enabled, so they probably can turn off all this stuff, so it's not available on WebViz. So this is probably how they compile the different production versus developer builds, which have the different interfaces. Here they have a pointer to the display implementation thing. I don't quite know what's going on there yet, but it looks like they might support down here with this console function, letting you change the display brightness from that web interface so that they could probably tune it and identify what the right values were on the fly. But it wouldn't be something that would be a preference setting or configurable setting that the application would have, at least not when they were originally creating this. That's what this looks like that they're doing here with all these different items to control. So going down to face display, that's the main constructor. It stops, so it sets up the signaling variables that are used for other threads to kind of tell this thread to stop running or to clean things up or things are ready. So it says, do we want to stop the boot anim in simulator? If we are not supposed to manually, okay. So they're checking to see if they're in a simulator or if it's been configured to manually stop the boot anim. If it's automatic, not manual, or in the simulator it says, yeah, it's gonna stop the boot anim by setting this flag. Somebody else probably looks at that flag and does it. No, I'm sorry. Yeah, this is the one that's signaled from the other task. So they are. I missed this comment right here. So system D takes care of stopping it. It could have been that. Who knows what the motivation for having this being manually stopped besides the simulator? They could have been trying different techniques out, and some of this could be considered obsolete, or they're perhaps supporting this on Cosmo in a different way than they are in Vector, and they needed to do another signaling. But right now it's not used, and on Vector strictly, it could probably be removed. The boot animProcess may be using the display, so we don't so it's going to wait for a little bit here to clear out the display until it's got some indication that the boot animProcess has cleaned up and stopped. And then they're going to set up some features that they use to draw what I think is the camera frame. So they have some buffers here to hold that, 2 of them. So they're probably going to bounce between populating one versus using one to actually display. And then they're going to create a thread right here that will actually be a loop, and we'll go look at that loop here in a little bit, of taking events and then doing something with the stuff and then actually piping that out to the display. So the destructor, they're going to clean up here. They're going to tell the thread to stop using the C++ idiom of how they do mutexes and locking and such. And then they're going to wait on that for the thread to exit and whatnot. So they use a condition variable as well. I'm not fully certain why they're using 2 things, but I think it has to do with the notification versus mutex. They need to protect some of that in some ways. It could be they're protecting the ready face variable. So update next image pointer. So let's see here. If it's null, they get the next image buffer, and if the current one is this, they go to the other buffer. Not fully sure what they're doing there, but they're probably just cycling through the 2 buffers, deciding which one's in use and which one's not. Draw face to debug. Allow face info screen manager to draw none in the screen in particular. Already clear. Not entirely sure what's going on there. Here's basically it's a wrapper to the display implementation to set the display to one of the internally predefined brightness levels. So they have 5 levels that we saw there, maybe 6, and then the hardware could possibly support 20 if we understand their comments correctly. Here they're drawing the face, so they're going to check to see, okay, is it actively drawing to display? If it's actively drawing, they're going to bail out. Otherwise, they call this draw face internal method. And this method, let's see here, let's go through. Oh, it's a little bit involved. So, okay, if the boot animation is still playing, they're going to skip out of this. So they're going to look at the flag there. Then they're going to lock some stuff to get at the buffer pointer here so that they can do it cleanly. And then they copy that image into that buffer, and then they use some signaling here to tell the thread that it can be drawn to. So this procedure is probably called by something not in the face drawing thread, but rather it's a helper procedure for other threads to send information, frame buffers, to this thread, and it does the proper locking and signaling so that the main loop can get at that, and other threads won't stomp on each other. So okay, so this is going to be the loop for the face drawer. Here they're just setting up a helper that kind of just reports the thread name to draw face loop so that any of the other debugging tools will know which thread this is, as opposed to trying to go through and step through all the different threads in a debugger trying to figure out which one is which. And looks like they're going to loop here. This is pretty classic. So they're going to loop here over these steps as long as the stop flag hasn't been set. And that's going to be one of the events into the loop. So if some external thread is told it to shut down because they're exiting, that will get set and they'll exit. All right. Note. Interesting. So this indicates that they've gone through a few different designs while they were working on the face drawing thing. They must have been looking before, using a certain technique before this notification variable, condition variable and notification on that condition. They must have been using something else, and we're trying to figure out how to get that to work smoothly. And then they switched over, but left in this profiling, which they were tracking to see how smooth it was. Okay, so now the loop is running. They do a lock. They check to see if the boot animation is stopped and there isn't a display, and then they work on creating an actual interface to the underlying display. So they're waiting to create that common shared display, especially the LCD, until somebody else has stopped using the LCD. Otherwise, they probably couldn't open up any of the requisite file descriptors, devices, SPI device, for instance, and get at that. And then if it's a remote console, it looks like they have a linkage here. So perhaps the remote console can see what's on the display. That's kind of curious. I wonder if that lets it see what's on display, or if that lets it send images and stuff to the display. We do know it controlled the brightness earlier. So okay, so it looks like face draw next image. That's probably a pointer to what it should draw next, and is populated perhaps by one of the other helper threads there that I missed, one of the other populated by one of those other helper procedures and called by another thread. So it gets the current image, sets that to this next image to display, and then clears that out so that it's just kind of a little queue, one or two items in that queue, and it takes it from the queue and clears that out. Looks like it's going to. This probably is just specific to C++ idioms here, where how they're going to get a reference to the actual image buffer and work with its locking. So, and they'll probably just pass that down here to the thing which actually does the face drawing. It looks like this buffer is probably kind of a smarter item where it probably has data for the pixels, but also probably a lot of information about it. And then they provide access to those pixels through this get raw data pointer method. It could be this is from the way the vision system works. It might even be OpenCV that they inherited from for this buffer. So again, they're kind of just checking to make sure there's something that actual to draw to, that the display has actually been opened up and the boot animation has stopped. And they clean up some of the mutex stuff there. Let's see, what's this say? Looks like what they're doing here is, if there isn't a currently connection to the display, because they're waiting for the boot animation to stop, it looks like it just goes and sleeps for 5 milliseconds. That looks a little bit strange if you're with all this stuff in front of it, but that's actually just the way of providing units to the sleep call. And then here at the bottom of the loop, they're going to wait until there's a signal from the other threads that there's something for it to display next. So it looks like the method here is that it depends on the item condition, waits on this condition, and when the other threads call it, it populates one of those pointers for the incoming image buffer to draw, and then does something to signal this condition. I think we saw that up here. Yeah, so right here is where that notification is probably sent, and then they're populating the buffers here. And it looks like they aren't just passing pointers around, but it's just one of the two buffers it controls, so if those other threads go away, they don't, any buffers they own, we have a copy of it. We're not actually getting a linkage to theirs, and issues with how on earth you manage two different parties potentially owning the same buffer. And if the loop should exit, they just log a message here for the debug information. So that makes sense. So it's going to loop around there. So here's their helper procedure for stop boot anim. If it hasn't been already stopped, oh, okay, yep, they're executing a command using system control to stop the systemd process. But systemd is taking care of that for this, so perhaps this code might be obsolete. So, or it could just be a redundancy. I don't know why they'd want the redundancy though. That I've usually had problems with Linux systems. If you try to be too clever at redundancy, you're masking a problem, and you wind up finding out much later that the problem's still there and it just came out in a different way. Who knows? Don't know if this is legacy or if they actually are trying to do this for a particular reason, but they're basically trying to use the system control stop thing to stop one of the system startup tasks. They tried a couple different ways, and then they go straight out to killing it. And this, and if it fails, they They log an error and then go to display fault code that they could not stop the boot animator. Wonder if that's ever happened in practice. Anyways, that is that file, and next time we'll try digging into more of how the eyes are drawn and how the procedural face adds in eye behaviors that kind of create those interesting blinking and glancing around effects.